For most of history, the human condition has been one of misery and struggle to survive. Basically, 200 years ago, we were all farmers. We were working over 60 hours a week, going hungry multiple times a year, and life expectancy was a mere 29 years. It's actually only the last 250 years that have been really transformational. The Industrial Revolution has led to an increase in our quality of life through technology that makes the life of the people in the West today the envy of the kings of yesteryear. And what is all the more remarkable is this has happened while human population has gone from 1 billion to 8 billion in the last 200 years. The issue is that this quality of life improvements have come from an increase in energy production or consumption, which has been driven by hydrocarbons. And so the amount of accumulated greenhouse gases in the atmosphere and the oceans is now actually threatening to change the climate and is becoming an existential threat. The amount of energy accumulated in the oceans in the last 25 years is the equivalent of detonating 5 Hiroshima-sized nuclear bombs in the last 25 years. And I'll let them figure this out. But so imagine aliens arrived and they started dropping nukes, five nukes a second. We drop everything to deal with it. But because this is invisible and felt to be natural, we've been complacent. To the point that about 1 million species are at risk of extinction in the next 40 years. We're probably at the point where we're going to have no more sea ice in the Arctic basin by 2040. And 20 of the warmest years of record have happened in the last 22 years. And the scale of the problem is so daunting that people have either felt we can do nothing for it or we need to degrow our way out of it. But the first one is pure nihilism, and the second one actually is not palatable. People do not want to go back to the quality of life of 200 years ago. So actually, let's look at the problem. So the main problem is coming from greenhouse gas emissions, especially CO2 and methane, coming from 4 categories: energy production, agriculture, industry, and transportation. And actually, if you look at each of these, progress is being made. When it comes to energy production, solar is now the cheapest form of energy production, and it's continuing to become cheaper by the day. Prices have fallen by 10 in the last decade. They've actually fallen divided by 10 in every one of the last 4 decades, divided by 10,000 in 40 years, and are continuing to decline. In fact, the decrease in the price of solar is faster than the most optimistic projections ever made throughout history, and we're continuing to do so. To the point that in the US, we've gone from essentially negligible energy production from solar to over 5% today. Most of the capacity being added today continues to be renewable, most of which continues to be solar. And this is not just a US phenomenon, it's happening globally. Solar and wind have become so cheap that massive capacity is being added at utilities globally. 12% of energy production right now is already driven by renewable on a global level and increasing extraordinarily rapidly. To the point that you can actually imagine, well, the issue, of course, is solar only works during the day and doesn't work in cloudy days. So you actually need a storage solution. And people worry that batteries are not effective. But batteries are now 42 times cheaper than they were in 1991. The price is divided by 10 in the last decade, and actually divided by 2 in the last year. And prices are continuing to collapse. To the point, at the same time, energy density is increasing dramatically. It's multiplied by 10 in the last 100 years, multiplied by 5 in the last 40 years. To the point that now energy or battery installations are exploding in use. We have a tripling of installations from 22 to 23, which is ginormous, expecting to double again in 2024. And it's actually having a real impact on how we are consuming energy. If you look at energy consumption in California in April 21 versus April 24, you see that the shift towards batteries and solar is marked and pronounced and is going to continue on a global level. Now, because solar and batteries have reached the level of scale and network effects, we can expect prices to continue to decline and penetration increase. The IEA, which is a very conservative organization, is now projecting that within 4 years, solar will be the largest share of energy production on a global level, which is unprecedented. So actually, you can imagine a world 30 years from now where 100% of our energy production will be coming from renewables, much faster than most optimistic forecasts. And this future may come earlier should things like fusion actually become commercially viable. Now, I suspect that it will not, and most of it will come from solar and batteries, and those will be the winning categories. But people were actually investing and testing so many other types of innovations as well, from energy or gravity-based storage to helium-based storage solutions, et cetera. Now, the same progress is happening in transportation. So in transportation, the issue is actually only cars and trucks. Planes and ships are marginal. And here, we're also seeing massive progress. In 22, 14% of the cars sold globally were electric. Again, up from nothing a decade ago, far outpacing even the most optimistic forecasts. And most of these are fully electric, by the way, rather than plug-in hybrids. And Europe and China are leading the way. About a third of the cars sold in China are electric, about a quarter of the cars sold in Europe are electric. And we're reaching the point where the IEA is again upgrading its forecasts. In 22, they thought that 23% of cars sold by 2030 will be electric. 23, they upgraded that to 36%. And I would not be surprised if more than half the cars sold by 2030 will be electric. And again, you can imagine a future 30 years from now where 100% of the cars on the road are electric and trucks, and where all of those are being recharged by renewable energy, completely decarbonizing both our energy production and transportation. Now, they're not a big source of emissions, but progress is even happening when it comes to flight. We have a company like Wright, which is trying to create short-range electric aircraft and should be operating by the end of the decade. And all of the arguments that people have made against batteries, solar, and cars are wrong. So people have fretted, oh, we're going to run out of lithium. So we have 7 times the reserves today and resources in lithium that we had in 2008, despite 16 years of record consumption. People don't imagine that we can find new technologies, new ways to extract them. In fact, there were so many discoveries of lithium that seems to be actually rather common in the US last year that the price of lithium has collapsed. And this is happening, it's actually even more optimistic in all of the other categories. Copper, nickel, all of the other elements that you need, or more common than people think, are finding even more reserves. Range anxiety when it comes to electric vehicles is also proving to be a thing of the past. Range is increasing by the day, and the density of electric networks to recharge is increasing. And people are also worried that, yes, you get emissions when you're extracting lithium and copper, et cetera, but you need to think of the scale of these things. In order to decarbonize your grid and energy in cars, you need millions of tons of copper and lithium per year versus billions of tons of hydrocarbons to run our economy today. We're talking of 1,000 to 1, so to the extent that these emissions are actually really negligible. Progress is happening in the other categories as well. Industry has been reasonably intractable because you need a lot of heat in order to create steel and cement, but now you're starting to see progress with concentrated solar, which is leading to progress in industry. You have really cool innovations like Source, which is a hydroponic panel that takes humidity from the air and creates fresh water, even in the desert, helping remote communities or refugee camps. Now, food is the one that is probably the least, or where the least amount of progress is being made. You have a small vegetarian and vegan movement in the West, but it's completely dwarfed by the increase in meat consumption in emerging markets as they're becoming wealthier. And while I actually feel for the animals that we mistreat, and I suspect the way people will look at us and the industrial food processes we have today in the future, the way we looked to slavery a few hundred years ago, the reality is for 8 billion people that we need to feed today, we need these modern agricultural techniques. Progress will only come when lab-grown meat becomes both of the quality of existing meat and at the cost. It's probably 10, 15 years away, but progress is slightly starting to happen. In the meantime, there are companies like Symbrosia that are providing supplements to cows and sheep, decreasing their methane emissions by 80%. It's like a seaweed-based supplement. And so progress is going to happen here as well, giving me a lot of optimism. So it used to be that if you wanted economic growth, you needed to increase your emissions. This is no longer the case. US emissions have fallen 20% in the last 40 years, while actually GDP per capita has doubled. And by the way, it's not because we've exported our emissions to China. When you look at consumption-based emissions, which are more accurate, they're basically flat to declining in the US, versus all the increase in emissions in China and India have actually come from increases in consumptions of those countries. Now, of course, emissions are still growing in China and India, but even there's a decoupling between economic growth and emissions. and progress is happening. Now, some of the more optimistic forecasts suggest that the emissions have peaked in China. I suspect that's not true. We're far from the peak. Nonetheless, the decoupling is going to lead us to have a similar approach in China and India than we have here. And so hope is on the horizon. And in the meantime, progress is being made on decarbonization with a number of companies working on removing directly carbon from the atmosphere. A few things worth mentioning. Because the marginal cost of electricity of solar is zero, you can imagine a world 30, 40, 50 years from now when the marginal cost of electricity is zero. And a world of energy abundance is actually a world of abundance, period. People are fretting currently that we're going to run out of fresh water, but actually this is nonsensical. 70% of the world is water. If you have infinite free energy, you can desalinate salt water. Likewise, we're not going to run out of food. If you have infinite fresh water, you can grow food in vertical farms. You can grow food in deserts. Now, this is not a Penglosian view. I'm not saying that all is for the best and the best of possible worlds. Far from it. We've accumulated enough heat in the oceans and in the atmosphere that the world is going to warm. We're going to go way past the 2030 projections. We're going to have to focus on adaptation, and we're still emitting more emissions right now as China and India are becoming wealthier. So adaptation will be required. But what I am saying is in 30, 40 years, we are rising to the challenge. We are going to build a better world of tomorrow, a sustainable world of plenty. Thank you.